Welcome Luke Kanies, CEO and founder of Puppet Labs and original author of Puppet.
So 10 years ago, when I started Puppet and Puppet Labs, I was basically a grumpy sysadmin. Anybody who worked with me then certainly knows that's the case. And there were so many reasons why I decided that I thought it was worth building a company, why I thought it was worth trying to build better software. The first one was, even in 2005 and 2003, there were companies out there who were doing great things. I mean, Google was kind of the standard for the best way you could build operations, the best way you could do automation. But Google was such an exception. There were so few people who actually met their standard, so few people who were able to do what they did. And I thought it was worth trying to build a software company that produced software that nearly everybody could use. Not literally everybody, but nearly everybody could use. And that's one of the main reasons why I started the company. I wanted to try to find a way to move the whole market, right? Because if only 10%, if only 5% of the market can use what you're building, then, I mean, it might be really intellectually interesting, but it's not really going to change how all of us work on a daily basis. So that's what I set out to do. I want to build software not for me, not for some of you, not for the absolute, leading edge, craziest people, but for just infrastructure, for nearly everything. The second thing is, sysadmins are grumpy, and they're grumpy for a reason. I mean, part of it's they live under bridges and the whole thing, but they're grumpy because studies show, on average, sysadmins get interrupted every 5 minutes in the course of their work. Studies also show that when you get interrupted, it takes you on the order of 30 minutes to recover from that interruption. So what this means is, if you're in the role of a sysadmin in an average, normal environment, if any such thing exists, then you basically spend your whole time like a rabbit in a bush waiting to get struck by a hawk. And when it happens, you run away as fast as you can, and then you do what you have to do your little firefighting, and then you kind of just stand there. Because there's no reason to do anything else. There's no value in going and trying to do other interesting things, because the very minute you just start to get involved, somebody's going to open a ticket. Somebody's going to come stand behind you and go, hey, you got a second? Or the minute you finally show up at the bar or whatever, your pager's going to go off. The proverbial pager. I don't think we actually carry pagers anymore, right? So what I wanted to do was build software that would allow you to take the parts of your job that are horrible and make them go away. Because I think the job is a really interesting job. We as sysadmins get so much opportunity to play with. It's not just some of the newest and most interesting technology. It's some of the most expensive technology. I mean, who else gets to play with stuff that costs as much as we get to play with, right? Who else gets to write $100,000 million checks and then be told in no uncertain circumstances you must go spend 2 weeks in the data center with that thing? And you're like, that's way better than an iPhone. So there are a lot of great things, but I wanted to build software that would help you, help me, help the market focus on those fun things, focus on the interesting parts of the job, and make the tedious, annoying, interrupt-driven parts of the job, frankly, hopefully, go away. And in no small part, we've done this to some extent, right? The way that I think about this is I want to take the parts that make you feel like a robot, right? The lever-pulling parts of your job, the parts that you feel like there are days where you feel like I could actually just be replaced with a short shell script. Take those parts, make them go away, and instead of trying to think of you like an automaton, think of you like I want to give you better armor. I want to give you rocket boots. I want to give you the best weapons that money can buy. I want to make you into a more powerful sysadmin. And the most gratifying parts of this job that in the nearly 10 years I've done this, or when people tell me, Luke, you've saved my career. I was done with being a sysadmin. I was ready to leave. I was ready to quit. Not because I couldn't get a job anymore. Not because people weren't willing to pay me to do the work that I was doing, but because I just freaking hated it. I couldn't do it anymore. I couldn't stand it. And you took the parts that I couldn't stand and you made them go away. And you took the parts that I loved, the parts that I enjoyed, and you made me enjoy them more. You gave me more time to do them. You made me more valuable to the company, and I might have gotten a promotion and a raise once in a while, too. So this is one of those areas where, it was really important to how we started the company, and again, really important to success going forward for us. The third major reason why I started the company was it was about helping people and helping companies evolve and change more quickly. So in the Air Force, started studying how to win battles of planes in the air. And you think about it, at a certain point, the concept of fighting in the air, it was begun anew, right? Before World War I, no one had ever had a fight in the air with a plane, right? So it's a pretty new concept. And after mid 20th century, they started studying it, and they developed what they called the OODA loop, the observe, orient, decide, act loop. And what they found in the course of their studies was, given two planes in a fight, and actually this worked out to be more than just planes, but it was most useful in planes. Given two planes in a dogfight, the one pilot who can have more of these loops in a given amount of time than the other one is going to tend to win. So if you get to loop 5 times and I get to loop 7 times, then they call that getting inside your loop. I can move faster than you can. I can act faster than you can. I can get more done than you can. And I think this is a decent analogy for what I want to help people do, right? I want to help you. It's not about moving faster, right? It's not about just getting bigger jets and going more quickly. It's about changing more quickly. It's about evolving more quickly. It's about actually driving more and more iterations over time. And if all I had succeeded at doing was building software that nearly everyone used and made you happier in your job, but didn't really change the market, didn't really change how we work, didn't really change how companies work, then I think that's a little less interesting. But if we can build things, if we as a company can build something that really actually changes because we can help you evolve more quickly, we can help you as a person grow and change more quickly, we can help your company grow and change more quickly, then that's pretty fundamentally interesting. And I think it's fair to say we made a lot of progress. There's nearly 2,000 people here today. Don't look behind you, trust me, I counted. And there's nearly 5,000 watching online. And like Alice's Restaurant, I really think this is a movement, and it is growing quickly. And it's aligned well. Really, no one got that one? All right. Thanksgiving, just look it up, you can trust me. It's aligned with a lot of other important movements. It's aligned, obviously, with DevOps, people who are trying to better align the role of operations with the purpose of the business. But there really is a lot happening just in Puppet. Dice.com last week said Puppet was the fastest growing technology skill in the market, faster than NoSQL, faster than big data, faster than cybersecurity, and a bunch of other things that none of us want to do. So we really have come a long way. We've done a lot of interesting things, and I think we should all be proud of what we've accomplished. And even in the course of the last couple of days, I keep meeting people who've been involved in this community for 8 years in many cases, far more cases than I would have expected. But I'm here to tell you that it's not just that we're not done. I think we've barely begun. I think you look at the Eiffel Tower, and you look at that base of the Eiffel Tower, and you say to yourself, that base probably, if you were to go into Paris in, what was it, the 1910, 1900, and see that base, it was big, right? It was a really impressive edifice. But compared to the final structure, it's not nearly it's not nearly so impressive, right? So I think we've got a lot more left to do. Just as a simple example, out there in the audience, think of all of the pieces of software you as a sysadmin love to use, right? How many is it? Raise your hand with the number of fingers for how many pieces of software you can think of that you love to use. Seriously. How many? I see a 1. I see a 5. That's overloaded, that one. Somebody's got 10. Not enough fingers. That's shocking. I was talking to somebody yesterday. Yep, I see a 2. He said, I've got 2, maybe 3. Right? And think of all the vendors who aren't producing software that you love, aren't producing software you want to use, that you still have to use to some extent. So I think there's not just a lot left to do. I think there's a lot of opportunity to do better things. And I think it's reasonable to compare the amount of work we have to do to the last 100 years of evolution and learning in the manufacturing industry. In 1913, Henry Ford first invented the moving assembly line. And he first started with the flywheel, and they got within just a couple of months, they got from 20 minutes to assemble a flywheel down to 13 and then down to 5. And that's pretty impressive. But the next year, they went from 12 and a half hours to assembling an entire car to 93 minutes, right? I mean, that's pretty fantastic. And if you compare that evolution to what we've done in the last 10 years, They did way better in a year than we've done in 10, right? So yeah, that was just 1 year. So again, there's a lot more we can do. But look at the last 90 years since then, right? Look at the 100 years since 1914, and you see they've done so much more. They've done lean manufacturing. They've done total quality management. And many of these things sound really, really stupid. But they actually had a really important impact on how we build things. And while we in software might think building physical things is kind of irrelevant, it turns out it can't be turtles all the way down. At some point, you do need to have physical stuff out there in the universe. And this is really what's led to the massive productivity increases we've seen all around the world for the last 100 years. And if you compare that to today, you compare that to how people build things today, the world looks incredibly different. There have been huge changes over the last 100 years. And I recognize that manufacturing is not the same thing as operations. It's not the same thing as software development. They have fixed inputs and fixed outputs in most cases, and we don't have that luxury, right? None of us ever get a spec. None of us ever get a clear success criteria for whether we've actually built what we're supposed to build or whether the thing really works the way it's supposed to work. I understand that, but in some ways that just means that we have that much more to do, right? They had an easier job than we do. So what leads us to believe after 10 years of doing interesting work that, you know what, we're probably done and, you know, we should, you know, there have been a bunch of acquisitions this week and people are talking about the great cloud consolidation. And I think this is the third of them, by the way. And for me, there's just so much more left to do. And it's the more left to do that I think is interesting. It's easy to get kind of hung up on the tools that are out there today and the things people are doing today and to kind of point inward and say, well, this thing or that thing or the other thing. And for me, I'm far more focused on what comes next, what the other 9/10 of the problem is. When you think back to that shift in manufacturing, just think of all that had to change to make that work. Because prior to making cars with an assembly line, cars were basically built in a coach building style mentality. It was essentially a single person would build the entirety of the car. The same person would build the wheels and the struts or whatever they called them back then. They would build the steering. They would be the person who designed the interface of the car. I don't suppose any of you have ever driven a Model T, but they're apparently impossible to drive and bear no relationship to the cockpit of a modern car. And no small part of that was it was all bespoke, every single aspect, just like our world today. And I think a reasonable analogy, the way that I think about what we have to do, it's not just about better tools. It's not just about more widely used tools. We have to really shift the entire mentality of our employers, our teammates, ourselves, our suppliers, our vendors. Essentially, everybody has to change how they think about the world. And I think of that change as a kind of terraforming. We have to come in, and we really have to scrape the earth clean and rethink a lot of it. And not necessarily in terms of the tools themselves, but in terms of how we think about the problem, in terms of how we can go about being set up so that in 100 years, we've actually made as much progress in software manufacturing as the rest of the world has made in hardware, in stuff manufacturing in the last 100 years. A big part of how we're going to do that at Puppet Labs, a big part of how we're trying to drive that change is really focusing on ubiquitous open source. We want the tools that you use, we want the tools that we build to be absolutely everywhere. We think that ubiquity will help us, will help you change the market faster, because it turns out that as soon as you have Puppet in place, as soon as you have these better tools, it's almost always easier to solve your problems through that than going around it. So we think that it'll help drive those changes more quickly. One thing we're doing in this area is we're beginning to move all of our clients to a native platform. We know that lower resource count, we know that smaller footprint, faster, more stable, not having to depend on the Ruby binaries, not having to depend on the Ruby runtime. All these things will help you run faster, help it be easier to adopt the technology. So the first example is C-Factor, which it's not technically, it's been on our GitHub site for a while, but we've rewritten all of Factor in a C++, into C++, and now it's a native binary for all the platforms we support, and it's also obviously considerably faster. We can ship static binaries, and this is the first step towards carving off parts of Puppet that run on the agent side and doing the same thing, rewriting those in C++ or some other compiled language that can run basically everywhere. We'd love to use Go, but it turns out Go doesn't really run on AIX, so Our commitment to ubiquity means we have to be a little more conservative in our runtime choices. But this is a great example of what we're trying to do to get the tools and the software that you rely on running in even more places. We're doing a similar change on the server side. The work we've done in the last 10 years was really about, OK, what do we have to do? What are the real problems? And the work we're doing now is really trying to set us up for the next 10 years. We're making investments in the core infrastructure on the server that do a better job of helping us move forward. So what we're doing on the server side is we're porting most of these services to closure. We've proven this out with PuppetDB. I had somebody yesterday say to me how afraid they were of running the JVM. They don't want to be using the JVM. They've not had good experience with it. And I said, well, do you use PuppetDB? And he goes, oh, yeah, we love that stuff. And I said, well, we're just going to do exactly that, but with new servers. And he goes, oh, yeah, we're fine. Never mind. So it's that same level of quality. It's that same reliability. It's that same consistency. But we've got a new Puppet server. It's a new front end to Puppet. Replaces your Apache, Passenger, Unicorn, Nginx complications with a more stable, more scalable, and more reliable service. And even better, when it does begin to fall over, because every service falls over at some point, it falls over in a way that's far more graceful. So it's not going to actually catch your entire data center on fire, just that one computer, for example. We're also making a lot of changes to the language. This is the largest set of changes we've ever made to the Puppet language since we first started, since we really had a single coherent language. And these changes fall along two major arteries. The first is we're trying to make the language more consistent. There are a few areas where it turns out I'm not the best language designer, and so there are a couple of kind of inconsistencies or maybe things that weren't entirely defined in the language that the team is finding, OK, for us to move forward, for us to be able to make promises to the market, we have to actually close these out. And that's been really important, right? Because if we want to build software that everybody can use, if I want to have a module that pretty much anybody can download, anybody can use from scratch, then it's got to be simple. It's got to be straightforward, and it's got to be easy to understand, easy to test, easy to maintain. And so the other artery is adding just a little more power. We always try to find the balance in Puppet between the power that we provide you and not making it so powerful that it becomes useless. One of the things I'm proudest of with Puppet is our customers can do things like hand logs and code to auditors. I mean, auditors, right? They can read Puppet code. That's an asset you don't want to lose. So you don't want to add so much power that you're trying to become a Turing-complete language, and then you kind of lose the benefit of being a DSL in the first place. So here's one example of how we've added data typing to the language that allows you to dramatically compress the amount of code it uses to do certain kinds of functions. We've also added iteration to the language so that in many cases you don't have to go outside the language. You can do a lot more inside of Puppet. And again, I was talking to somebody yesterday, a customer who said he has 5 people in his organization who can write plugins and types and do more complicated Puppet, but he has 50 people who can write just Puppet code. So this is about taking those 50 people and giving them just a little more ability, a little more power. And my goal ultimately is to make Puppet the lingua franca of the data center. When you speak infrastructure, I want you to speak in Puppet. When your infrastructure talks to you, I want your infrastructure to speak to you in terms of Puppet. When you have tools that do any kind of querying, any kind of analysis, any kind of state checking, or any kind of state validation, I want them to all use Puppet. And to do that, we've got to have a simple, strong, powerful DSL. And no, we can't do it with YAML. We can't do it with JSON. And we certainly can't do it with Ruby, right? Because you've got to have the benefits of both the syntax, the consistent syntax that everyone agrees how to talk about it, but you've also got to have the semantics that go with the language. They've got to actually have the same meaning, right? If all of us speak the same language, but all of us have entirely different meanings for each of the words in that language, we're kind of not really speaking the same language. A huge part of helping to make our tooling and also the language itself more ubiquitous is the module forge. My goal is to have 80% of the problems that you have in your infrastructure, that any average organization has, that there be a module that you can find easily, download, and use in production without modification. We're pretty far from that goal today, but we've made a heck of a lot of progress. We've got 2,700 modules in the Forge right now. We've been adding about 100 a month. And our focus continues in this area to just expand the Forge. And for the last 2 years, it's really been about adding more modules, getting the quantity up there, because we really didn't understand we didn't have enough modules to study the problem of what does it take to make it so that everybody can use a module? What does it take to make a truly reusable module? So for the last year or so, and for the next, I would say, between 2 and 200 years, we'll be focusing on how to take not a high quantity of modules, but to how to make much more quality modules. So right now, we're announcing Puppet-approved modules. And these are modules where we at Puppet Labs work with a module author, either at a partner of some kind or just someone in the community, to make sure that the modules are meeting our standards for composition and design. They have accurate and thorough documentation, and they have, frankly, active maintenance. Right? There's nothing worse than finding a module that's nearly right that's basically been abandoned. So we also make sure that they follow things like semantic versioning so that you can make some promises about, hey, if I deploy this and I deploy a point release update, what is that going to mean for me? What kind of promises can I expect from the software? The first 12 modules we're launching under Puppet Approved include Elasticsearch, Jenkins, and Cloudera, but we expect to add a lot more modules to this program in the near future. Second, we've got Puppet-supported modules. And these are modules that we at Puppet Labs actively maintain, that if you're a customer of ours, you can get support for them. We think it's important not just to have high-quality modules, but to be able to have a conversation. Right? We've heard this from customers again and again. When I have a problem, I want to be able to get help. I don't want to be the person who's responsible for all these modules. I don't want to be the person who has to take ownership for every one of them. And so for the base modules that absolutely everyone uses, that need to be everywhere, and that, frankly, not that 80% that kind of many of us have, but the 30 or 20% that every one of us has to deal with, customers would like a different standard for that. So Tomcat and Java are available right now, added to already a pretty long list of modules that we support at Puppet Labs. And in Q4, we'll have Microsoft SQL, F5's RESTful API support, and Arista support. I swear to all of you, I was much funnier in my practices. We obviously didn't write all 2,700 of these modules. And the community is such a huge part of success across this entire system, right? So much of what makes open source valuable, so much of what makes open source great is how much opportunity for improving the product we get from interactions with the community, right? Just a good example is those language changes I was talking about. They're in the future parser in Puppet, which you can try today. And one of the ways we're getting more and more confident every day that we'll be able to ship with the future parser enabled is that so many people are trying that today. And that community involvement is really a big part of what helps bring the maturity we have, what helps bring the stability we have, and really just what helps us accomplish what we're trying to do. And for the first time, I want to take the opportunity to recognize a few of some of our most valued community members, and I want to give an award to the most what our community itself has voted as the most valuable puppeteer. Tim Sharp has been involved in Puppet for a long time, and one of the things he's done the most of is he's really produced the best, most widely used testing tools. If you aren't using Puppet Lint and Puppet RSpec today, your code is lower quality than it could be. You can use these tools right now, and they will help you immediately improve the quality of your code. Even better, they'll help that person sitting next to you who seriously always breaks the build. They'll help that person improve the quality of their code. Felix Frank is a long-time contributor and one of the all-time top mailing list participants. And the mailing list, seriously, I used to be, for a very long time, I was that top participant. And I can tell you, it takes a lot of work. It takes a lot of energy to do that, and frankly, anything else. And to maintain the level of both interaction and quality that Felix has done, all while at the same time contributing to core types and fixing long-standing bugs, it really makes a big difference. I know some of you in the audience have been out there tracking those 3-digit and 4-digit bugs that have been there forever that you just so want to die. Well, that's one of Felix's goals too, right? He wants to track those down, and he wants to kill them. And he's done a great job working on those. Daniele Sliders has also done a lot of really interesting work. He's done things like built the Puppet board, which displays PuppetDB data on a web-based dashboard. And he's also been one of the more helpful community members on IRC in the mailing list. And I talked a little bit about how great the mailing list. We also have one of the largest IRC channels. I think we have the 12th largest IRC channel right now. And the IRC channel has also always been a really important part of our community. And to have people like Daniele, or Danny as he usually is called, out there helping really makes a massive difference. But the community agrees that the person who's done the most in our community this year is Eric Delian. He's a prolific contributor who's helped push Puppet and PuppetDB forward. Very much so. Part of why PuppetDB is so great is because Eric just beats the crap out of that thing. He's worked closely with the team on all the big designs. He brings a very good user perspective to the product and also a developer's perspective. He's used the API and has used the application itself and has built PuppetDB Query and now Puppet Explorer to really help improve both the overall ecosystem and the core technology we all rely on. So I just want to ask you to say thank you to all these community members for the great work that they've done. The work that we're doing today, again, we have a lot left to do, and the work we're doing is a delicate balance, because I know we have a lot left. I know we have to keep moving as a company. We have to keep moving as an industry, as an organization, and as a community. But at the same time, I don't think any of you want me making drastic changes to the product or the projects every week or every month or every quarter. So we have to find a way to find this balance between maturity, where I can make promises and we can keep promises, and you can have clear and met expectations on the software you use. But at the same time, we as an organization can keep moving, we can keep developing, we can do new interesting things, and it doesn't break that core platform. So we're happy to announce that we're going to begin extracting a lot of the key functionality, a lot of the additional functionality built above the platform into Puppet applications, where these applications will be independently installable, they'll be independently upgradable, and the idea is that they'll both be independent of the platform itself, so that when we update one of the applications, you don't have to worry about changing the platform. They'll also be decoupled from each other. So you might be able to look at upgrading or running the most recent version of one of them, and hopefully have the other ones maybe moving a lot more slowly or moving a lot more quickly. So the idea is to give both us and the community a lot of opportunity to move more quickly where it's warranted, but be a little slower in the other parts of the system. And anybody who's using PE today, anybody who's got a PE license is going to have the right to use these Puppet apps. The first one of them is the Puppet Node Manager. And this is a new node classifier from us today. It's a rules-based classifier, and it's a lot like Smart Playlists. Any of you who have used iTunes know it's very easy to build a playlist based on attributes of the songs, so you're not looking at building a manual playlist. You're really looking at saying, look, anybody who's got these attributes, I just want it to look like this. If you're using Linux, I'm sorry, you've never actually heard an MP3 before. I know it's nearly impossible to play audio there. But trust me, it's a great experience. So the Node Manager works the same way. You go through and you have these attribute-based groups that you build. And in the long term, the Node Manager, these groupings are going to be an important part of the entire system. You're going to rely heavily on these groups for a lot of other work that you do. And in the first place, it's really just focused on being the new best classifier you can use. But you'll see us add a lot of functionality to this in the near future. And again, the idea behind this Node Manager is we need to be able to update it quickly. We need to be able to iterate it quickly because we know there's so much more we can and should do in this application. And to show you some of the interesting things this application can do, Dan Literal-Porter is going to come on stage and walk through some of the features and functionality.
Hi, I'm Dan Literal-Porter. I've been working on the closure backend of the Node Manager since I joined Puppet 9 months ago. And I'm really excited to finally get a chance to show all of you a little bit of what it can do. So I'm at the Node Groups page of the Node Manager. And the Node Group, as Luke mentioned, is the fundamental unit of the Node Manager. It acts as a container for nodes, and it matches them using rules that care about their attributes rather than their identities. And once groups match a node group, once nodes match a node group, then it assigns them classes, class parameters, sets the environment, gives values for top-level variables. So let me show you an example. This is my web servers group. It matches all nodes that have web in their host name using a regular expression. You can see we have a count of how many nodes are currently matching, and we can see a list in the Matching Nodes tab. Over in the Classes tab, we see that we've added the Apache class to all of these nodes. And if I go over to the Nodes page in my PE console, at the top of the individual node page, I can see that it's in the web servers group, and it's received the Apache class. Now, let's say that I'm concerned about my public-facing web servers, and I want to add a little more security to them. So I'm going to do that by creating a new group called Public Web Servers that's going to inherit from the web servers group by setting that as its parent. Now, I can do this because I'm logged in as an administrator who can do anything. But we've added very fine-grained access control rules to the manager to allow you to restrict who can do this. So now I'm going to put nodes into the public web servers group based on their IP address. And I'm going to use a regular expression to reject the nodes that look like they have a public IP address. And as you can see, we have 15 matches. There's a lot more nodes that have public IP addresses in our infrastructure, but because this inherits from the web servers group, it's only receiving a subset of the nodes that the web servers group cares about. And over in the Classes tab, I'm going to add fail to ban on these nodes. I'm getting type ahead, that's environment-aware type ahead, that pulls the classes that currently exist in this environment on the master. I'm going to add this rule, so now it actually works. And we can see that we've matched the nodes already. So I'm going to go in to the node detail page for that node and refresh it. And you can see it's already picked up on its new classification. It's in the public web servers group. It's getting fail to ban from that group, and it's receiving Apache from that group, which it inherited from the web servers group, even though we never explicitly specified it in the public web servers group. So that's a little bit of what the node manager can do. I'm excited to get it out the door to all of you in PE 3.4, and even more excited to see what you build with it and to hear from you how we can make it better. Thank you.
Thanks, Dan. And where can they come hear more about the application, how to use it, and what kinds of interesting, crazy things they can do?
So we have a demo station across the hall that I'll be manning and other people will be manning throughout the conference. And I'm giving a talk tomorrow morning at 11 a.m. in track 4 on the node manager's domain model.
Excellent. Thank you.
Thank you, Luke.
I'm pretty excited about that one because it's really aligned with this, this goal in your infrastructure of thinking of your servers as cattle, not pets, right? You shouldn't have an emotional relationship with your server infrastructure. And this really helps. You can see he never really cared about any of those individual servers. It's really about, hey, let's make sure all the machines that look vaguely like this get this ability. And so, especially for those of you who have highly dynamic infrastructures, or any of those, or you just have so many servers that you can't think about the individual machines, I think that'll be a great fit. We're working on a bunch of other areas about adding applications, encapsulating the functionality that you do in a specific area into an application so that we can grow and iterate that more quickly. Obviously, a big part of what people use Puppet to do today is configuration management, but we think there's a lot more we can do to build really coherent, concise workflows around those use cases so that it's not just, hey, here's a bunch of tooling, here's a toolbox that we throw on the garage floor for you, go figure it out, but really building a single consistent application. Similarly, while we know Puppet is often used in application management today, we know there's a lot more we need to do and we can do to help you do things like manage more complicated applications, manage applications that run across multiple hosts. And I really hope to have something very, very interesting to show you in maybe early 2015. I'm really hoping to do that. So I think we're going to take a lot of the things that make Puppet great right now, a lot of the things that have really helped Puppet succeed and spread as wildly as it has. We're going to take a lot of those same concepts and apply them across your entire environment rather than focusing on one host at a time. But even better, not even better, but right now, we've done a lot of work in the Puppet server to make it so not just the Puppet server is better, You don't just have a better experience with better software and faster experience, things like that. And I guess I forgot to mention, but this new Puppet server, including client-side improvements in Puppet Enterprise 3.4, it's between 2 and 3 times faster for most network operations. So it's not just better hypothetically, it's actually better in experience, it's faster, all these things. But even with that, we know there's more we can do to help you understand what's going on in your environment. For people who have large infrastructures, you end up with a large Puppet infrastructure. You end up with a complicated Puppet infrastructure. And you end up, when things break, when things go wrong, it can be very difficult to figure out what went wrong, right? We had one customer who wrote a function that took 50 seconds to run. And they called us and said, wow, Puppet is incredibly slow. This is absolutely useless. And it took us a while to figure out, OK, well, if you just change this one little recursive YAML call to a much less recursive YAML call, suddenly Puppet is no longer slow. So this kind of thing it's tough to track down because there isn't a lot of tooling available to help you understand what's going on behind that TCP socket. So we've been working hard. We built an instrumentation service, an activity service, into the new Puppet server that can help you understand what's happening. And we've got a feed of all the activity coming from this service describing what's happening, how often it's happening, when it's happening, how quickly it's happening, all these kinds of things. And I think it's going to be a really, really great tool for those of you who are managing large infrastructure or for anybody who's trying to figure out, seriously, what the heck is going on. And to show this new metrics service, Chris Price is going to come on stage and walk through what kinds of things you can see and how you can get access to it.
Hi, so I'm Chris. We're going to do a very quick tour today of a few of the new features in the PE Puppet server that'll be in the next Puppet Enterprise release. Specifically, like Luke said, we wanted to make sure that we provided a lot more visibility into what's going on inside of your server at any given moment in time. So we've added a metrics service that kind of keeps tabs on some of the more interesting things that we think people need to know about. And another thing that's cool about it is you can configure it to export the metrics to different external systems that you may already be using in your own shop to do monitoring, things like that. So one of those systems is Graphite, a really popular, common metrics reporting server that I imagine a lot of you are familiar with. And another thing that's great about Graphite is there are a lot of existing third-party web UIs that allow you to build cool dashboards on top of the particular metrics that you care about. And so one of those dashboards is Grafana. That's what I'm going to be using for the demo today. Grafana has a cool feature where after you build up a dashboard, you can export it as a JSON file and then copy it around, load it back up anywhere else that you'd like to. So I'm going to do that right now. I have a JSON file on disk here that is kind of a pre-baked dashboard that shows some of the interesting metrics that are available in Puppet server. So right now, just a bunch of flat lines, not too interesting. So what I'm going to do is I'm going to jump over to this other desktop, and I am going to kick off a run of a bunch of Puppet agents that'll be checking in with that Puppet master that we were looking at there. So now I'll jump back over here, and we should see these graphs starting to show some reactions to the load that has started to appear on the master. So I'll start off by I'm just going to click into a couple of these graphs today. We have a demo that will be running through the entire conference right across the hall from here, where we'll go into a lot more detail on all of these graphs. So if anyone's interested, please stop by and say hi, ask questions, and stuff like that. So this graph right here is sort of intended to be kind of a health check for the server. The green line will show the number of cores that you have in your system, and the other lines will show the number of HTTP requests that are being actively processed by the server at any moment in time. So generally speaking, as long as the number of requests lines stay well below the number of CPU lines, you're in really good shape. Your server's doing a great job of keeping up with all the traffic that's coming in. But if those lines start to go above the number of cores, then that's showing you that you're starting to get backed up a little bit and that your server is not quite able to keep up with the load that's being generated. So another graph that's pretty interesting is this one. This is we're breaking down all of the HTTP requests that the agents are making to the master into the main different categories of requests. So we've got our catalog requests, our report requests, and some requests related to retrieving files from the server. So this is cool because it gives you a really stark visual representation of which of those requests are the more expensive and whether any of them are in particular are trending one direction or another. And one thing you'll notice with Puppet Server is that right when you start it up, the JVM will do some optimizations on code paths that get executed frequently. So the first couple of times you have certain types of requests coming in, you'll see kind of this spike where they look a little bit expensive. But then they'll level out over time as the code is optimized behind the scenes.
And C Ruby doesn't do that?
No, not quite, no. So now what I'm going to do is, we're at a pretty steady state here. The server's handling this amount of load just fine. So what I'm going to do is I'll jump back over here, and I am going to increase the number of agents that we're running to an amount that I happen to already know is a little bit beyond the capacity of what this particular master can handle. And so once those requests start coming in, what we'll see is that the lines on these graphs start changing pretty drastically, pretty quickly. We should see on the active request graph, the total number of active requests will start jumping up to numbers that are approaching the green line and kind of giving us an indication that we're starting to enter the danger zone of whether this server can handle this amount of load. And at the same time that line starts trending up, you'll also see that the response time for every individual type of request that we're looking at here is going to start curving upwards. So that's an indicator, as these requests are starting to take longer and longer for the master to handle, that's a pretty clear indication that it's getting a little bit behind, that there's an excessive amount of load being received.
Yeah, when your graphs reset their axes, you know something's changing.
Yeah, and what's really interesting on this graph is you can see every single type of request is trending upwards at the same time. So it's not, you can very clearly tell from the graph that it's not just an issue where like your catalog compilation got more expensive all of a sudden, but like every single type of request is taking longer. So that's a real clear picture that you've got a lot of excess load there. So now that the fan in my MacBook is starting to tell me that it's angry with me, I'm going to jump back over here. And if you think that's something, you should, man, if you come to see our demo across the hall, we do some really mean things to the fans in those servers over there. So I'm going to change the amount of load back down to the more manageable amount. And now I can jump back over to the graphs, and almost instantaneously we'll see those requests that were trending upwards so sharply start to drop back down towards normal levels. And so that gives us, again, a really clear indicator that we've started to address the problem and things are getting back to normal. There's a lot of other cool stuff on these graphs. I'm not going to go into too much detail on it other than to show this one really briefly. This one kind of hits on a point that Luke was talking about a little earlier. This graph gives me the ability to see the average execution time for any different function that I'm calling during my Puppet catalog compilation. And so for this demo, I wrote a function. It's called myExpensive function. And as you might guess, that's the blue line up here. That function is proving to be significantly more expensive than any other functions that are running in my catalog. But that gives me a really clear picture that, hey, maybe I can go do something to that function to make it perform better, and that'll help the overall throughput of the system. So that's all I'm going to show for now. But again, please come check out our demo across the hall. We'd love to talk to people about it and answer questions and stuff like that. So thank you very much.
Great.
Appreciate it.
So where can they find out more about this application, how to use it, what it can do?
So in addition to our demo across the hall, I'll be giving a talk tomorrow in track 4 at 2:20 p.m. where I'll kind of dive into some of the architectural decisions, show some of the things that we brought over from PuppetDB that have made this project successful, and hope to see some of you there.
Great. And I know you didn't have time to show it in this demo, but can you talk just really briefly on how this works if you've got, say, 2 or 5 or 15 Puppet servers?
Sure. So yeah, actually in the demo tomorrow, rather than Today, what I did is I artificially adjusted the amount of load up and down to what this server could handle. In the demo, what we actually do is we start up a single Puppet master, and we increase the load slowly until we've exceeded its capacity, and then we add a second Puppet master to the mix with an HA proxy load balancer in between them. And we show you the graphs of both of them at the same time, and you can see the second master pick up the slack and how everything gets back to normal. So,
Excellent. Thank you, Chris.
thank you.
So although Charlotte hates to hear me say it, when I started the company 10 years ago, I did so out of fear and desperation. It was desperation because I was living in Nashville, Tennessee, and seriously, who wouldn't be desperate living in Nashville? But I was having a hard time not finding a job, but finding an interesting job, as I mentioned earlier. And I was kind of desperate that I was still going to be doing the same thing in a long time. I was still going to be having to be the same kind of sysadmin. And I was afraid that the market just wasn't going to change. I was afraid that 10 years on, 15 years on, we'd be using the same tools, we'd be having the same jobs, IT would still feel like a cost center, sysadmins would still feel completely disconnected from the goals of the business. And I'm really, really happy to say that that's not what happened, right? And obviously, it's primarily my doing, but I think others have helped. I really wanted to create a world where I'm not bored, where you're not bored, right? I think all of us, we didn't get into administration, we didn't get into IT because, we wanted to be bored. We wanted the most drudgery-like role we could find. And I think it's a great time to be in this role, right? It's a great time to be in this world. I don't know that you can be so lucky as to be in such an interesting place, such an interesting time where all the assumptions, all the beliefs that you have, that your team has, that all your vendors have, the entire market, everybody in the market is having to ask themselves fundamental existential questions about what the world is going to look like in a few years. Again, it's that process of terraforming taking place where the world we're going to have is going to be entirely unrelated to the world we have. And I don't think anybody really knows what that new world looks like. So I just want to encourage you to stay involved, stay actively trying to understand, trying these new things, trying to figure out what can I do? What will the world look like? What are these better things? How can I move things? And you've got to stay flexible, because the one thing I can guarantee you this new world will look like is different from today. So you're going to have to keep learning. You're going to have to be willing to spend a bunch of time on stuff that ends up being useless and stupid. You're going to have to spend a lot of time being wrong, being confused. You are going to have to evolve your own skill set. You're going to have to painfully help your company evolve how they think about operations, how they think about infrastructure. Because we all have a lot to learn between now and that 20th step 80, 90 years from now. So go, do this, build more, push the boundaries. Thank you very much. Wrong direction there. Normally, I would try to do a Q&A at the end of this session, but there are just too darn many of you today. So we're going to do a Q&A tomorrow. You can submit your questions at this URL right now. And my collection of PR flunkies between now and then will select from those questions the ones that make me look best. And you'll get a chance to, it won't be quite so scripted, probably. You'll get a chance to be a little more interactive in that session. So please come by there. And I look forward to that. And then I also, please, come to PuppetConf next year. It's the second week of October, or the half of the first. Anyway, it's the second week of October. And I'm frankly really excited because next year, it's coming home. We're going to have PuppetConf in Portland, Oregon next year. And if you haven't been to Portland, you are in for a treat. It is a fantastic city. It's great food, great drink, great beer, great coffee, great city, great land, great people. The weather will probably be nice. I don't know about great. August is fantastic. October is nice. So I hope to see you all there next year. Thank you very much.